Hello Year 12s and welcome back to Mathematics. In today's lesson, what we're going to go through is a few data displays that we use in statistics and actually how to read off information from these data displays. Now, some of these you may have seen in Year 10, which was, I believe, the last time you looked at statistics before we looked at it in the senior course. So this might require you to dig back quite a bit, but hopefully by the end of this lesson you should be able to get a good understanding of it, and we'll give you a few questions to have a go at as well. So in today's lesson we're going to talk about a few different graphs. The first one is a frequency histogram and Polygon. Then we're going to look at a cumulative frequency histogram and Ogive. And then finally looking at Pareto Charts. So that's the three things we're going to be looking at in today's lesson. So first thing that we're going to look at is a frequency histogram. Now a frequency histogram here, this is on page 14 of the booklet. A frequency histogram is visually similar to a column graph. So a frequency histogram kind of looks like a column graph, but the distinct difference about it is that but with no gaps between the columns. So when you're drawing a frequency histogram, or if you're reading off a frequency histogram, the thing that you're going to notice is that they don't have any gaps between the columns. So the next thing is the subintervals on the horizontal axis of frequency histograms is often called bins. I didn't even know that. Now, important notes about our histogram and a few key things that you're going to notice. When constructing a frequency histogram, the first column is usually placed 1/2 column width from the vertical axis. So when you draw your histogram, what you're going to do is when you draw your axes, so here I realize I shouldn't have any arrows going there. Actually you can. When you draw your first column, what you want to do is you want to leave a 1/2 column gap. So this is going to be half of the length of this column. And so here, when you're drawing your histogram, you want to leave a 1/2 column gap at the start. The second bit, which we already mentioned, is that the columns join up with no gaps. When you draw each one of your columns, there's not going to be a single gap between them. The next point is each column is centered on the value for individual data. So what you're going to have here is you're going to put the center of each individual score here. So for example, you might have 1, 2, 3, and so on. Or you can also have it centered on a class center. So we talked about this yesterday when we looked at frequency tables. We could actually group a certain data. So in our frequency tables, we said that we could have our scores 1 to like 9, then 10 to 19. And so instead of putting the score like 1 to 9, instead we'll put this class center in the middle. So here 1 to 9, that the middle score I believe was 4.5 we said. And then you have 14.5 and so on. What you can also include is sometimes you might also see a scale break or zigzag on the X and Y axis to indicate that the data display does not include all the values that exist on the number line used. So you have a look here on this example, they've actually put in a zigzag there. This is, so here we've got two examples of a few polygons. So what you notice is this one is a little bit skewed, but if you have a look at this one over here, you've got a 1/2 column gap at the front, and the scores are centered at the bottom of each of the columns, and there's no gaps. Okay, so that's one of our first data displays, the histogram. Now the second part is the polygon. Now a frequency polygon is a line graph often constructed on the same graph as a histogram. So if you have a look at this second example over here with maximum temperatures, the polygon is just that green line that's drawn on top of the histogram. So the histogram is just an orange bit underneath, the orange column graph that has no gaps and has a 1/2 column gaps on either side. And then the polygon is just the line graph above it. Now with a polygon, what you do is you plotted points at the center of the top of each of the columns. So notice here, this actually connects the center of the middle of each one of these columns. So it connects the center of all of those columns. Then they are then joined by intervals, so they're joined using lines. And the polygon starts on the left on the horizontal axis or at the previous value or at the class center. So if you have a look here, they started at the previous value and they ended at the next value. or class center, which is what the next dot point says. So that's a frequency histogram and a polygon. So what we're going to do over the page is actually go through an example of creating a histogram and a polygon. Important note, coarser groupings in frequency histograms is more practical as too many columns make the data display difficult to interpret. Okay, so let's have a look at this example. At the start of year 7, Cedar Heights High School gave 40 students, I'm going to write here, 40 students a spelling test marked out of 10. So here the raw results are organized into a frequency table below. So here we've got our frequency table. It's horizontal, but here we've got all our marks from 1 to 10. And here underneath we've got the frequency showing how frequent each one of those scores appear. Part A. What we want to do is we want to draw a polygon, a frequency, let me try that again. Construct a histogram and polygon for the original data. So what we want to do is we're going to create a histogram and polygon. So what we're going to do is we're going to create our axes. So here the highest frequency was 8, so I only need to go up to 8. So here I'm going to go, let's actually make it go up to 10 so I have a little bit of room to work with. So 6, 4, 2, 1. So that's our scores, or actually that's our frequency. And then our scores are at the bottom. What we want to do is we want to leave a half column gap at the start. And so here at the bottom, I'm going to have 1. We're going to leave a half column gap at the start. And I'm just going to make my columns 2 blocks wide to make it easy for me to work with. 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are my scores. So this is my marks. Let's just put X here. And all we need to do is we need then draw our columns on here. So here, 1 had a frequency of 2, so I'm just going to draw a column of height 2. 2 had a frequency of 4, so I'm going to go and draw a column of height 4. Now the way, one way that I've noticed is a nicer way of doing this is draw all the horizontal lines first. Actually, I'll show you how I would normally do it. I'm just going to draw horizontal lines to represent the top of each of these columns, and then I'm just going to show you what I do at the end. Then I've got, what's in my next one? I've got 3 had a frequency of 2. 4 had a frequency of 1. 5 had a frequency of 6. 6 had a frequency of 8. 7 had a frequency of 7. 8 had a frequency of 6. 9 had a frequency of 2. And 10 also had a frequency of 2. And I realized I need to leave a half column gap on the other end too. So then once you've done all your horizontal lines, all you need to do is just draw vertical lines and make sure they cover all of the columns, and this just makes it a little bit neater in my opinion, instead of having to draw multiple vertical lines. There we go. So I've created my frequency histogram. So a frequency histogram, just a regular column graph, but just no gaps, and you want to leave a half column gap at the start like this and a half column gap at the end like that. Okay. The next thing we need to do is we also want to create a frequency polygon. Now, frequency polygon, all we need to do, connect the dots from the top of each of the middle of each of these columns, and also the ending points there. So here I've got all those dots, and all I need to do is just draw lines connecting the two. Connecting the lines, I mean. Preferably you'd want to use a ruler. However, after having me teach you guys for 2 years, you would have known I'm very meticulous and love being lazy. And there we go. We've created our frequency histogram and our polygon on the same graph. A little bit messy, but that's okay. Okay, first part we've done. We've created our frequency histogram and our polygon. Part B. Construct a frequency distribution table by grouping the data into subintervals of 1 to 2, 3 to 4, and so on, including a row for the class centers. So what we want to do here now is, instead of using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we want to actually use, so for part B, we want to create groups, intervals we'll just call them groups. And so we want to go from 1 to 2, 3 to 4, 5 to 6, 7 to 8, 9 to 10. So these are the groups that we're going to be working off. And here they've actually asked us to include another column just for this, what's it called? The class center. So these are classes, that's what we call them. Classes. And then we're going to include a row for a column for our class center. Now here, class center is just the middle value for those particular values. So here, 1 to 2, the middle value is going to be 1.5. Next one's going to be 3.5, 5.5, 7.5, and 9.5. And the final bit was we want to find the frequency. And for this, all we need to do is we just add up the frequencies for 1 and 2 together. So here 1 and 2 had a frequency of 2 and 4, so I add that up, so it gives me 6. 3 and 4 had a frequency of 2 and 1, so I add those up and it gives me 3, and I just repeat this process. 5 and 6 had a frequency of 6 and 8, so that gives me 14. 7 and 8 had a frequency of 7 and 6, so that gives me a frequency of that class of being 13. And 9 and 10 had 2 each, so that gives me 4. So for this table, all we needed to do was just group into those particular classes. So 1 to 2, 3 to 4, 5 to 6, and so on. Figure out the class center by finding the middle value and just adding the frequencies of those two individual marks together to find it for those classes. Okay, final part was we wanted to find, part C. Part C is we want to construct a histogram and frequency distribution polygon for the grouped data. So here, what we want to do is do exactly the same thing that we did in part 1, but instead use our new table here and our class centers. So what I'm going to do is I'm going to go, okay, well, the highest frequency was 14, so this time I'm going to actually go all the way up to 14. I'm going to go like this, 1, 2, so here I've got 0, 2, 4, 6, 8. Let me try that one again. 10, 12, 14. I'm going to go a little bit higher just so I can leave some space above. And then over here, I'm going to include my, instead of using those individual scores, I'm going to go class centers. So here I'm going to put here 1.5. Just make sure you leave a half column gap at the start. 1.5, 3.5, 5.5, 7.5, and 9.5. And I'm just going to I realize I went a bit too far, so I just need to go up to there. Oh, goodness gracious, I cannot draw straight lines. There we go. This is our X, is our frequency, and all we need to do is the exact same steps that we did before. So we're going to create a column graph with no gaps. So here 1.5, that was class 1 to 2 and had a frequency of 6. So I'm just going to draw my horizontal line here. 3.5 had a total frequency of 3. 5.5 was 14, which is all the way up here. Next one was 13, which is all the way down over here. And the last one was 4 for 9.5, which is over here. So here, I've got my frequency histogram drawn like that. There we go. Okay, so that's for our frequency histogram, and the next bit is we just need to draw our polygon. So we're going to draw our dots in the center of each one of those columns and at the start and at the end. And all I need to do is just connect the dots. So here, connecting those dots. And there we go. We've created our frequency histogram and our polygon for our data set here. Okay. So, final step. Compare and comment on what the two data displays have shown. Now, if you have a look at the two data displays, what we kind of notice is that for the first one, we've actually got like most of our scores being between 5 to 8, and there's a little bump at the start at 2. And similarly here, the second data display actually shows very similar data. We've got most of our scores are actually towards the middle between 5 to 8, if you have a look at the columns, so most of them are centered around the middle there at 5 to 8. So that's what I'm going to just say. So compare and comment. So the two data displays both show most scores are found around 5 to 8. Okay, cool. So that's how we create a frequency histogram and a polygon. Okay, so that's our first type of graph covered, our frequency histogram and a polygon. Let's move on to our second one. Our second one is our cumulative frequency histogram and polygon. Now, if you remember from the last lesson, we talked about creating our frequency table. And so we created a frequency table where we had our scores, our frequency, and we can also include a third, an extra column for our cumulative frequency. And how we get this is we just add up all our frequencies up until that point. So for example, for this one, if I have frequencies of 1, 2, 3, 4, I just add on my frequency. So here, cumulative frequency for this first one is just 1. The next one is 3. The next one is going to be 6 because I add on that 3 onto my 3. And the next one will be 10 because I add that 4 onto my 6. A cumulative frequency histogram is just the same thing as our frequency histogram, but instead of using our frequency scores, we're going to be using our cumulative frequencies. So the height of, if you have a look here, cumulative frequency histogram is formed by stacking the columns of a frequency histogram. So what we're imagining is, we're taking each one of these individual columns and stacking. What's it called? Let me try that again. Each one of the columns for each of the scores is just going to be taken by stacking on all the previous ones on top of that score. So here, the height of the last column of a cumulative frequency histogram is the sample size. Oh, well, let me try. Find here the total size of the sample. So if you have a look at this example, this one for example, so this one's the exact same. This one uses the exact same data that we saw on the maximum temperatures from a couple pages ago. So if you have a look here, the columns are actually increasing because what we've done here is we've actually stacked each one of those columns on top of each other until we get to the end. So that's our frequency histogram. Now the frequency polygon, just like we did in the previous example, is we're creating a line graph. It's also called an Ogive. So cumulative frequency polygon is also called an Ogive. It shows the cumulative frequency. Let me see if I can spell things right. Cumulative frequency. So it's drawn slightly differently. So here, if you have a look at the diagram underneath, what you notice is that this cumulative frequency polygon, or this Ogive, kind of looks a little bit different to our frequency polygon. If you have a look, our polygons were usually connect at the center of the columns. This one, it doesn't do that. And so here there's a few rules that we're going to follow. So when we're constructing a cumulative frequency polygon, the polygon starts at 0 at the bottom left-hand corner of the first column. So if you have a look here, it starts at the bottom left-hand corner of that 17 column. The polygon then passes through the top right-hand corner of each of the columns. So if you have a look here, what it does, it goes from the bottom there and it goes to the top right-hand corner of each one of our columns. And like so. And it finishes at the top right-hand corner of the last column. So its height is equal to the total size of the sample. Now I didn't quite mention this in the previous lesson, but about the cumulative frequency. But what the cumulative frequency is really great for, and so is cumulative frequency polygons, these are really great for finding the median. So it's great for finding a median or our middle score. From last lesson we talked about how the median was the middle score. The reason why this is the case is because the last column just tells me my last column here, or my last value in my cumulative frequency column, tells me the total number of scores that they are. So this tells me how many scores there are altogether. So if I want to find the median, all I need to do is just find the middle of all of that. So the middle value And all I need to do is just read that off from my vertical axis, and that gives me the median. So for example, this one over here, this cumulative frequency histogram and Ogive, if you have a look, the final score is up here, and so that's kind of telling me that there's a total of 30 scores. So if I've got 30 scores, the median is going to be in the middle, so that's going to be 15, but because it's an even number, it's going to be two numbers. It's going to be my 15th and my 16th score. And so all I need to do is just find my 15th and my 16th score. And so how I do that is I look at my cumulative frequency. So I'm going to find where 15 and 16 are. So 15 is over here, 16 is over here, and all I need to do is just read across here onto my Ogive and just read down, and it tells me that the 15th score would be 21 and the 16th score would also be 21 as well. And so this is actually a really helpful tool in helping me find a median. The cumulative frequency is actually really helpful in helping us find the median for a set of data. So let's have a go at an example where we need to do this. So this is the same set of data with our spelling test on example 8. What we want to do is for this one, this particular example, what we want to do first is we want to insert a cumulative frequency row and construct the cumulative frequency histogram and Ogive for this data. So let's have a go at this first one. So A, we've got our marks. So here I've got my marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are all my scores. And they've given us the frequency, so that's 2, 4, 2, 1, 6, 8, 7, 6, 2, 2. All we want to do is just add on our cumulative frequency column. So for this, all we need to do is we go, okay, I start with my first frequency, 2, and I just keep adding on all the frequencies after that. So 2, I add on that 4, and that gives me 6. Add on that next 2, which gives me an 8. Add on that 1, gives me a 9. Add on that 6, gives me a 15. Add on that 8, gives me a 23. Add on the 7, gives me 30. And what I should expect is, if you remember from the first question, they tell me that 40 students completed this spelling test. So at the end, I should expect that the last number should be 40 as well. So let's just continue with this. Add on 6, that gives me 36. Add on 2, gives me 38. And the last one, 40, which is exactly what I should expect. Okay, now that I've done that, I'm just going to draw my cumulative frequency histogram and Ogive. So here, I go all the way up to 40. So I'm going to go here, 40 up here. I start all the way down at 2. So I'm going to actually go up by 4s each time. So 40, 36, I need to get 10. So that's 10, 9, 8, 7, 6, 5, 4, 2, 1, 0. Okay, cool. So here, if I go up by 4s each time, I've got 32, 28, 24, 20, 16, 12, 8, 4, 0. So these are my this is my cumulative frequency, and over at the bottom I'm just going from 1 to 10. Now here, similar to our histogram, we just want to ensure that we've got gaps. There's no gaps between my columns. So here I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are my scores. This is X, and so I'm just going to draw on my columns for each one of these scores. So if you have a look on my cumulative frequencies for each one of these scores, so if you have a look on my right hand column, so X had 1 had a cumulative frequency of 2. Let me just draw the top bits and then we'll go down. Oh gosh, I can't even draw that. 2, then I went up to 6. Ooh. 6, 8, 9, 15, 23, which is up here, 30, 36, 38, and then 40. And so once I've done that, I'm just drawing my did that wrong already. Drawing my vertical lines down and making sure that there's no gaps between these columns. Almost there. And there we've created our cumulative frequency histogram. Yay, we've done that. The second part is then we need to add on our Ogive. Now with our Ogive, we start from the bottom left of our first column and go to the top right of that column, and we just put our dots at each of the top right of each of our next columns, and then we connect the dots. And so here we connect the dots like so. There we go. So we've created our frequency Ogive as well. So with our Ogive, we need to start from the bottom left of our first column and we just connect it to the next top right of the next column. Okay, there we go. So we've created our frequency histogram and cumulative frequency histogram and Ogive. Now we want to also do this for the grouped data, but I'm actually going to ignore that because I don't have enough space underneath, I don't think. What I want to do is actually I want to skip to part D, where we're going to find the median of the original data. Now what I said was when we want to find the median, what we want to do is we want to find the middle score that we required. Now here we have a total of 40 scores. That's what the original question told us. So if we want to find the median score would be the 40 divided by 2, which is the 20th score. But because it's also an even number of scores, we'd also need to include the next one up. So it's going to be our 20th and our 21st scores. And we average those two together. So once I figured out what scores it's going to be, I'm just going to go into my Ogive. I'm going to look at my Ogive. I'm going to find the 20th score by looking at my cumulative frequency. The cumulative frequency just tells me what adds up all those scores that exist, all those previous scores together, and so previous frequencies together. So by just going to the 20th, that actually gets me the 20th score. So here 20 is over here, so I'm just going to go over to here. Actually, let me do this in a different color pen so you can actually see it. Ooh. So here I'm going to go to my 20th score. I'm going to go read across that. And 21st, which also happens just to be over here. And if I read down, if you notice, both of them are in this 6 score. So both the 20th and the 21st score is actually 6. That's what this tells me. So therefore, my median is just going to be 6 plus 6 over 2, which hopefully you'll notice is just going to give me 6. And so that's how I can find the median from a frequency, cumulative frequency polygon. Okay, let's have a look at another question. This is from the 2010 general HSC question. And so here, let's just read through what the question tells me. A new shopping centre has opened near a primary school. The survey has conducted to determine the number of motor vehicles that pass the school each afternoon between 2:30 and 4 o'clock. The results for 60 days have been recorded in a table and displayed in a cumulative frequency histogram. And so here we've got this table and also the histogram underneath. If you notice in the table, we've actually got this X that is missing. And so what this merely tells me is probably one of the questions is going to be asking me to find what that X is. So let's have a look. Part I, exactly what I predicted. Find the value of X in this table. So if you have a look, we've got this missing value from our frequency, and we want to find out what it is. They've given us, we don't have this particular value, but they've actually given us the cumulative frequency. So we can actually work backwards to figure out what this value is. So if you remember, the cumulative frequency is just by taking on all the frequencies of all the scores before that. So if you look, we started off with 10, which is great. But then after we've had 10, we've added on this X value, and that's given me 25. So what number will I need to add on to 10 in order to give me 25? Well, that should just give me 15. So by adding on that 15, I should get that 25. And so we can actually check this score because they also tell us that it's been done for 60 days. If I add up all my frequencies together, what do I get? 10 plus 15 plus 20 plus 15. That gives me 60, which is exactly what I should expect. 60 days. So those are two ways of actually getting this same answer. So here we could use the cumulative frequency, or we could use the fact that this was done over 60 days, and so we should expect that the frequencies add up to 60. So first part, the value of x on this table is actually 15. Part 2, carefully copy the cumulative frequency histogram and draw a cumulative frequency polygon or ogive for this data. I'm just going to draw it right on top. So with our ogive, we start from the bottom left of our first column. Let me try that again. We start from the bottom left of our first column and we just connect it with the top right of that column, and then we continue this process. So here, I'm just going to draw my ogive. 1, 2, 3, 4. There we go. Okay. So I've drawn my ogive. Part 3. Use your graph to determine the median. Show by drawing lines on your graph to arrive at your answer. Now with the median, all we need to do is we look at our cumulative frequency histogram and ogive, and we find what score we need for the middle. Now if you have a look, there were 60 scores altogether, 60 times that cards were recorded. So for our ogive, for our median, we just want to find the middle of that 60. So the middle score is going to be 60 divided by 2, which gives me 30. It's going to be our 30th score, but because it's an even number, we're going to need to also include our next one, so 31st as well. So once we've done that, we're just going to go to our cumulative frequency, our y-axis here, and then just go to where 30 is, which is over here, and 31, which is just a little bit above that, and just read off where those two values would be. And now they both happen to be in the same group of 162. So here, I'm just going to write here, the median is 162. Okay. Now part 4. Part 4 is the one that requires you to actually do some reasoning. Prior to the opening of the new shopping center, the median number of motor vehicles passing the school between 2:30 and 4 was 57 vehicles per day. What problem could arise from the change in the median number of motor vehicles passing the school before and after opening the new shopping center? Briefly recommend a solution. Now this one doesn't require too much mathematics, just using a bit of logic here. Well, originally they had 57 vehicles and now it's 162, so it's almost tripled the number of cars that are there. So here, when you have more cars, it endangers school children, particularly because it's 2:30 to 4, which is the school zone time. And so you need you might want to include just figuring out suggesting ways that you can limit that, or suggesting like traffic lights or something like that. So here, I'm just going to write more cars equal endanger children during school zone time. A solution that you could have, so you could recommend anything, so more traffic lights, or you could suggest that all the students go do athletics training so they can get faster and they don't get hit by cars. That's a random suggestion. Do athletics training. Make the kids faster and they can't get hit by cars. That's legit. So you can just suggest anything here. Okay, cool. So that's our frequency, our cumulative frequency, polygon, histogram, and ogive. Okay, that is our two graphs there. We're going to talk about a few more before the end of this lesson. So please do hold on. We're going to talk about the next one here. So the next part is looking at distribution of data. So this isn't actually a particular graph, but it's just patterns that we notice with our data. So the shape of a statistical display indicates the distribution of the data. So clustering occurs when the scores are close together or bunched up. So usually when you get a set of data, most of your scores are actually going to bunch up around a particular value. So for example, a great example of this is heights. When you collect heights of a whole population of people, there's actually you eventually notice that it becomes a little bit bell curved. Most of the scores are centered around the average, and you've got most of the people are close to the average height, and there's a few people on either end. There's a few really short people, and you've got a few really tall people on the opposite end as well. And so clustering is when you get all these bunched up scores together. So definition 20, a symmetrical distribution has scores balanced or evenly spread. Evenly spread about the center of the distribution. This distribution is also unimodal. So notice here, it's kind of like we've got this center value here, and most of the scores are evenly spread either side of it. So you've got most of the scores being clustered near it, and it spreads out. And this distribution is unimodal. There's one most frequent score usually. Distributions with scores that are approximately even spread about either side of the central distributions with scores that are approximately evenly spread about either side of the center of the distributions are still classified as symmetrical distributions. Okay, the distribution is bimodal. So here, if you have a look at this next diagram, the distribution is bimodal and has two modes. So if you have a look, there's actually two tallest columns here, and so this is what bimodal data looks like. So you've got kind of like a cluster near the first one, and you've got a cluster near the second one. Okay, flipping over the page, we've got a few more definitions that we want to talk about before we move on. This next part is talking about skew. Now, skew is a really important concept to understand. A data distribution is skewed in the direction where the data is spread out. There is a long tail in this direction of the distribution. So if you have a look at these two, the data is clustered at the opposite end. So let me just put here, clustered in the opposite direction of the skew. So if you have a look at both of these sets of data, most of the data is actually pushed towards one side, and you notice that there's actually a long tail, like kind of like where there's less scores on both of them. So here you've got this tail is over here, and over here you've got the tail over here. And so this is where the scores are spread out. So here, these two distributions have particular names. So this first one is called positively skewed. Positively skewed. So if most of your scores, so what it says is where the tail is, so where the scores are more spread out, if it's on the right hand side, that means it's more on the positive side. So that's what it means by positively skewed. So this is skewed to the right. Most of the scores are relatively low. So you have a look here, most of the scores actually push towards the left, yep. And so that means you have more lower scores, and that means you have, this is skewed positively. On the other hand, if most of the scores are pushed towards the right, so the skew is to the left, that means it is negatively skewed. So when you talk about skew, you're talking about where the tail is, where they're like all the spread out scores. So skewed to the left. Most of the scores are relatively high. So that's what skew is. So this is just a concept you need to be able to understand and remember about what skew is. Now we're going to talk about one more type of chart before we finish this video. The last type of chart is called a Pareto chart. Now a Pareto chart, let's just go here, and there's actually quite a few spaces to fill in, so do bear with me. The Pareto chart consists of a column graphs with columns arranged in descending order. And a, what's this one called? A cumulative percentage line graph drawn in the same chart. So we're going to have a look at an example of this in a moment. And I think over the page there is an example of this. Yep. Here, there's a few key features that we need to know. So the chart usually has two vertical axes. So the first one is my frequencies on the left and cumulative percentages on the right. Now the reason why these charts exist, and actually if we flip over the page, if you have a look here, so this is what a Pareto chart looks like. It consists of a column graph. So if you have a look, we've got column graphs, and the columns are ordered in descending order. So notice here, the columns get smaller and smaller as we go towards the right. On the left, the other graph that is involved in the Pareto, the second component of our Pareto chart is this line graph, and this is our cumulative percentage chart. So this tells me that the percentage of each one of these particular columns, and cumulative, so it's just adding up together. So at the end, it should be 100. The next feature is then on the left-hand column. This is usually our frequency for our column graph. And on our right-hand side, this is a cumulative percentage for that line graph component. So this is what a Pareto chart it looks like. Now, the purpose of a Pareto chart. So the purpose of a Pareto chart is to identify the, and I realize it's the most significant problems, particularly in quality control. The line graph indicates the added percentage of each problem. So what these usually, the added contribution, contribution, that's the wrong word, I had looked at the wrong thing. So the reason why these Pareto charts are used is because they're usually identifying particular problems, and what they want to do is we want to identify what are the biggest weaknesses in a particular issue, particularly when they're looking at quality control. And so here you want to see what percentage of does each one of these things contribute to the problems that they're looking at. And so yeah, so this is why we have them in descending order, and they also include that cumulative percentage line graph as well. Okay, if the line graph rises steeply and levels out, the first 2 or 3 problems have the most impact. So if you have a look here, the first couple, if you have a look at this Pareto chart, the first couple are really steep. These lines are fairly steep, and you start to notice that it tethers off. The lines get less and less steep. And so the first couple of issues are usually the ones that are the biggest. And that's what companies usually identify when they're looking at this in quality control. If a line graph rises at a steady rate, all problems have roughly equal impact. And so the columns will be at similar heights. So if, unlike the one that we have looked at on the following page, if they have roughly the same heights of our columns and the Pareto chart looks like it's going up at an even rate, it just means that they all have the same impact, and there's no kind of like major one contributing factor to our quality control. So similar heights. The column graph is plotted using the frequency column of our frequency table and arranged in descending order, and the cumulative line graph is plotted using the cumulative percentage column. So I talked about that earlier. For our column graph, so the column graph, we're using the frequencies on the left-hand side, and for our line graph, our cumulative percentage line graph, we're using the cumulative percentages on our right. So let's have a go at this example. So this one's from the 2020 sample paper. A school collected data on the reasons given by students for arriving late. The Pareto chart shows the data collected. And so here we've got the different reasons. So slept in, not looking at anyone in particular in our class. Family, appointments, train or bus delays, then traffic problems, and a car breakdown. So these are the reasons that people give for being late. And here the column graph shows you the number of times each of these late arrivals happen. And you've got that cumulative percentage. Now with the cumulative percentage, actually let's just, we'll talk about this as we go through this. So the question is, what percentage of students gave the reason for train or bus delay? So here we're looking at this particular train or bus delay being the reason for them being late. Now what we want to do is we want to find the percentage of students that gave this particular reasons. Now if you have a look at train or bus delay, and if you have a look at the dot for our percentage, it's all the way up here at roughly 92%. So that's 92%. Now if you have a look, 92% is one of the options. But if you have a look at the column for train or bus delay, well, if you look at this column and compare that with the other ones, this doesn't make up 92% of all of the other scores, unfortunately. This column looks fairly short. It's not as big as, for example, sleeping in. No one in particular. So here, immediately you might be thinking, hang on, this doesn't make any sense. It can't be 92. And so using that logic, you just trust your brain sometimes. Like the logic, your logic should hopefully hold out here. Like this column here shouldn't represent 92%. That doesn't make any sense. Now, to actually find the answer for this, we actually need to be able to read off the cumulative percentage. Now, just like we did in our cumulative frequency histogram and polygon, the cumulative percentages here actually add on from all the previous parts. So what this 92% actually tells me is if I add on the percentages for sleeping in, family, appointment, and train or bus delays, all these four categories contribute to 92% of the reason that people are being late. So the way that we actually want to read to find the percentage of train or bus delay being the cause, we want to actually look at, well, how much does it jump from the previous one to this one? So for example, let's just actually go through the percentage, cumulative percentage section. If you have a look at this dot, this first dot, that's at roughly what? 38%. That tells me that this first column of sleeping in contributes to 38% of all of the reasons that someone was a student is late to school. Then if you have a look at the next one, this dot for family is at roughly, let's see, where is that roughly? That's like 77%. So what this tells me is if I add together sleeping in and family, that both of these categories contribute to 77% of all the students being late. And so what this means is if I want to find the number of people who said family was the reason why they were being late, I just go, okay, 77 minus my 38% that I had from people that were late because they slept in. So here, this is just, I believe, 29%. So 29% of people were late because of family. The next one is appointments. And so appointments, if you look here, that's up at 86. So that's 86%. So if I want to find how many people were late because of appointments, I just look at 86 and look at the previous one, 77, and subtract 2. So here, this one will be 9%. And so if I want to find train or bus delay, all I need to do is I go, okay, this is 86% here. This is 92% here. All I need to do is just subtract those two. So here, 92% minus 86%, that gives me 6%. So if you have a look, 6% is the answer over here. And so if we want to read off a Pareto chart, if we're looking at the percentage part in particular, we need to just make sure that we're reading it correctly. We want to look, for each one of these columns, it's cumulative. That percentage is adding on, is because we've added on the percentage that this contributes, this 6% contributes, but it's adding on from all the previous reasons as well. Okay, let's go over the page and we're going to go through this last example, and then I'm going to leave it there and go through the next part in class, I believe is my plan. Yes. Okay, cool. An online seller of clothes summarized the complaints received in a month in the following table. So here's all of the complaints. So you've got problems completing the order online, difficulty accessing the website, cancelled order, and so on. First part A. We want to fill in the table's percentage and cumulative percentage columns. What we want to do is we want to find out what percentage do each one of these particular complaints make up of the total number of complaints. So in order for us to do that, we need to find out how many complaints were they made all together. So to find that, I'm just going to add all of these together. So I'm going to grab my calculator out. I'm going to add these all up. So for this first part, I'm going to add these all up. So I've got 50 plus 30 plus 9 plus 5 plus 4 plus 2. That gives me 100. So 100, this is actually quite nice for me. So it adds up to 100. So when I'm finding the percentage, all I need to do is just write these as percentages. So this is just 50% because I do 50 over 100 and times it by 100. 30%, 9%, 5%, 4%, and 2%. There we go. Okay, cool. Now we want to look at cumulative percentage. Now cumulative percentage, just like we do in our cumulative frequency columns, all we need to do is just add on all our percentages together. So here I have 50%, then add on the 30, 80%, add on that 9, 80, why can't I write? 89%, add on the 5, 94%, add on the 4, 98%, and then add on that last 2%, which is 100%, which is what I should expect. The next part, we want to construct a Pareto chart for this information. So what I want to do is I want to have my frequencies on my left column and my percentage on the right hand column. So here I'm just going to go frequencies. I'm going to go from 50 and I'm going to go down by 5 each time. I think might be the plan. So 50, 45, 40, 35, 30, 25, 20, 15, 10, 5. I was off by 1, 0. So this is our frequency. We're going to leave enough room so we can fit in columns for each one of my reasons. So I have, how many reasons do we have? Complaints we have? 1, 2, 3, 4, 5, 6. 6 complaints. I've got 1, 2, 3, 4, 5, 6, and on the other side all I need to do is just have my cumulative percentage. So cumulative percentage, so I go all the way to 100. So if I would go by that, 0, so 50 every time I go up by that, that's a fifth. 20% is up every 2 boxes, 40%, 60%, 80%. So there we go. Okay. So for my Pareto chart, then I just put on my columns first. So I'm going to put in all of my reasons. So the first one was problems completing the order online. Order. I'm just going to shorthand this. Accessing the website, I'm going to say is called access. Cancelled order, cancelled, wrong, article sent, overcharging, and the last one was late. And so here I'm just going to put in my columns. So for my what's it called? For my order was wrong. There was 50 of them. Access, it was 30 of them. The next one was 9. Cancel was 9. Wrong order was 5. Next one was 4. And final one was 2. So we want to make sure that this is in descending order. So we want to make sure that our columns are in descending order, and then we draw the column graph there. Next thing is we want to also include the cumulative percentage. And so here I'm just going to go for, draw a dot in the middle of each of my columns for the percentage. So what we found was that this first one was 50%. So 50% is over here. Next one was a cumulative of 80%. So 80% over here. Next one was 89%. So 89 is roughly about here. Next one was 94, which is roughly about, where am I? It's over here. Next one was 98. And then the last one was 100. And so for the cumulative percentage line graph, we just connect the lines up here. There we go. Okay, we've constructed our Pareto chart for this information. Part C was which problems account for 80% of the complaints. So we're just going to look on the right here for 80%. We're going to look across. And we notice that 80%, that lines up with access. But that's not just access. That's access and also anything that has happened before it. So ordering and access. Here, I'm just going to write here what problems. Ordering and access website. And so there we go. So this is quite a lot of stuff in this video, and I apologize for it being so long, but this covers all of the different data displays that we need to be able to read off and also construct. So hopefully you stay well, Year 12s, and hopefully this long video didn't bore you. And as always, stay safe, stay healthy, stay wonderful, Year 12s, and I'll see you guys next lesson. Bye.